Let's do the APSTAT review for Chapter 6. So in this one, a vending machine operator has determined the number of candy bars sold per week in a certain machine is a random variable. So it's a random variable, mean 125, standard deviation 7. His profit on each bar sold is 25 cents. So his profit is going to be 0.25 times the number of candy bars sold. And then you have to subtract $5 because that's going to take away from the cost. $5 is subtracted no matter what. No matter how many bars you sell, you have a cost of $5. Which of the following gives the correct mean of standard deviation for Y? I guess I should call it Y, which is the profit. So this is Y for this in a selected week. So what's going to happen to this mean of 125? So if we have 125, you might want to get your calculator out here. So it'd be 125 or 0.25 times 125 minus 5 should be your mean, because both multiplication and subtraction affect the mean. Standard deviation is different. So subtracting a value doesn't affect the standard deviation. So I'm just going to take the standard deviation of 7, multiply that by 0.25, and I should get my answer there. So it should be, looks like E there for that one. Okay, so this one says roll one 8-sided die 10 times. What's probably getting exactly 3 7s in those 10 rolls? So this seems binomial. Let's just check. Binomial means success or fail. Rolling a 7 is success. Anything else is a fail. Independent, they seem independent each die roll. The number is set or fixed, and there's 10 times. And the probability is fixed as well. So the same, so that would be, so you have a chance, a 1 in 8 chance of getting a 7 every time you roll. Okay, so it's definitely binomial. So we're going to use the binomial theorem. So NCR or NCK, I guess in this case. So it would be 10, choose, we want to get exactly 3. So that's our starting point here. They write it a little differently. They don't, so it's that first part. So it's going to be either A or B or E here because they write 10 over 3 there because it's going to be 10, that's a 10 there. So 10, choose 3 times P, which is 1/8 to the K, which is exactly 3 here. So this one's gone, right? So then Q, which is 1 minus P, is 7/8 to the N minus K, which is 10 minus 3 power, or 7th power. So that one doesn't seem quite right. It's got to be B. And then just work that out. You type that in your calculator, type in NCR. It's your probability, I think. Okay. There are 20 multiple choice questions in an exam, each having a response of, there's 4 choices there. Each question is worth 5 points, and only one option per question is correct. It's probably obvious. Suppose the student guesses to answer each question, and the guess from each question are independent. The distribution of X, the number of questions the students will get correct, is what? So is it binomial? Does it pass the test for binomial? Okay, so there are 20 questions. The number of questions are set. Probability is 1/4 every time. They seem independent. You can either get it right or wrong, correct or incorrect. So it is binomial. So it's probably going to be A, B, C, or D there. N, you just want to figure out what N is. N is going to be the number of questions. That's 20. The probability for success is 0.25. I could have stopped at N equals 20 when you look at the answers. There it is. Small class has 10 students. 5 of the students are male and 5 are female. I write one name of each student on 3x5 card. The cards are shuffled, and I draw cards one at a time until I get a card with the male student. Let X equal the number of cards drawn. The random variable X has which of the following distributions. So until I get a card with the name. So when I saw this, keep drawing until you get a male student. I thought, well, maybe geometric. So I'm like, probably not one of those guys. Doesn't seem to have a set number of trials exactly here as far as what we're trying to get. So I was leaning towards geometric, but then with geometric, you have to have the same probability of success. And so like the first person who makes a draw, like the first choice here, the first card, I guess, would be a 5 out of 10 chance of choosing a male. Let's say you don't get a male on the first card, then the next chance would be 5 out of 9. It changes. So that's not geometric either, so it's got to be none of the above. It doesn't quite fit the bill for geometric because the probability changes with each draw of the card. There's no replacement of the cards, and so it's changing. Market survey compiled data from a total number of televisions in households. If X is the number of televisions in a randomly selected household, and we omit the rare case of more than 5 televisions, then X has the following distribution. So we're omitting more than 5. That seems excessive, maybe. I don't know. So hopefully that adds up to 100%, or it's not a valid probability model, if that makes sense. So if you add those up, trying to do that in my head, it does add up to 100%. So it's a valid probability. I wasn't sure. The way they said that, I was like, uh-oh, maybe it doesn't add up to 100. It does. What's probably the randomly chosen household had at least 2 televisions? You have 2 ways of doing this. You could add up all of these, 2, 3, 4, or 5, add up those numbers. Or you could do 1 minus the sum of these 2 numbers. Either way, I think you get 39 when you add those up. So you're adding up the probabilities there. It's not too hard of a problem. Jocelyn has a babysitting business. Based on daily sales figures for the past 2 years, she's developed the following probability. Daily profit, sometimes she gets 0, she doesn't babysit. Sometimes she gets $30, but that doesn't happen that often. So what's the expected value of X? So this is just that formula. It's 0 times 0.2 plus 10 times 0.4 plus 20 times 0.3 plus 30 times 0.1. And just type that in your calculator and see what you get. And when you type it in, you do get 13. Okay, a poll shows that 60% of adults in a large town are registered Democrats. A newspaper reporter wants to interview a local Democrat regarding a recent decision. On average, how many people will a reporter have to stop before he first finds a Democrat? So I'm leaning towards geometric here. It does seem like it's a fixed value of 60% chance every time he walks up to someone. So I think we're going to go with geometric here. So the formula for, on average, it's asking for the mean. So the formula for mean, I think for geometric is 1 over P. The probability of success is 0.6. Because I'm going to do this one by hand, I'm going to write that as a fraction. So 1 divided by P is, I think that's 3/5. So the reciprocal of that would be 5/3. You can also type in 1 divided by 0.6 in your calculator. I think that's 1 2/3. That would be C. Feel free to type that in your calculator. You get 1.666 repeating. In a large population of college students, 20% have experienced feelings of math anxiety. If you have a random sample of 10 students from this population, the mean and standard deviation of the students in the sample that have experienced math anxiety is what? Okay, so we have, so this seems, does it seem binomial to you? So it seems that, let's see, 20% of students, a fixed rate, exactly 10 students, so that's fixed. They seem independent of each other. As long as we're sampling less than, less than 10% of the population, I think this seems just fine. That's the condition, so I'm assuming that's probably true here because there's probably more than 100 students at the school. Okay, so the mean formula for binomial is n times p. So that would be 10 times 0.2, which is 2. So I know it's one of these. It's not one of those guys. And the formula for standard deviation is square root of n times p times q. So we get your calculator out and type in square root of n, which is 10 times 0.2, and q is 1 minus p, so 0.8, or the probability of failure. You type that in and get your answer. Okay, so when you type that in, you get E, 1.265 for the standard deviation. A worn-out bottling machine does not properly apply caps to 5% of the bottles it fills. If you randomly select 20 bottles from those produced by the machine, what is the approximate probability that between 2 and 6 caps have been improperly applied? So again, this seems binomial in nature, so you're going to go binomial. It's fixed, independent. You have exact number you're looking for, but it's binomial CDF because it's a range of values there. So definitely a range between 2 and 6. So binomial CDF, the lower bound would be 2, upper bound is 6. I'm not sure the order of the syntax of the commands in binomial. You might have to look that up. And then you put the mean, or the number. P is, so P is equal to 20, or N is equal to 20, and P, the probability of success, is 0.05. Weirdly, success is getting a bad lid here. Okay, so this would be 20 and 0.05. And again, you want to make sure to show this work, you want to label your lower, upper, your number or N and your P. Like label those things so that you get full credit on the AP exam. When you do that, you get 0.264, and you got it. Let the random variable x represent the profit on a randomly selected day by a certain store. The distribution of x is approximately normal with a mean of 360. You almost would just want to start drawing this. Standard deviation of 50, so that'd be what, 410, 460. I know it's kind of sloppy. 510. Just go out 3 standard deviations each direction. So 310, 260, 210. Really sloppy, sorry about that. Okay, so then 400 or more, we want to get greater than 400. So 400 started in here, we're shading this way. It's a good picture of it. You want to use, of course, norm CDF. Lower would be 400, upper is infinity. The mean is 360, standard deviation is 50. And again, make sure to label lower, upper, mean, standard deviation. And when you do that, you get a 0.211. Okay, we're on to free response. So the Picard Partners is planning a major investment. The amount of the profit X is uncertain, but research department has provided the following probability distribution. So find and interpret the mean of X. So you use that formula where you do the amount times the probability. So 1 times 0.2 plus 2 times 0.5 plus 4 times 0.2 plus 10 times 0.1. So this is equal to exactly 3. So this kind of investment was made many, many times. The average profit would be, and then you have to look, 3 is measured in $1 million. So the average profit would be about $3 million on average. So that's expected value is the mean, which is what we just found. Sometimes we even notate it like this, capital E of X equals, you'll see that notation sometimes. We found the mean, so on average, that would be about 3 million. Trying to interpret the standard deviation. So I would use your calculator for this personally, so get your calculator out. We're going to type in the lists here, so we're going to go list and spreadsheet, and we'll call the first one profit, and the second one we're going to call probability. So 1, 2, 4, and 10, and then 0.2,
0.5, 0.2, 0.1. Okay, so we're going to do, let's go to calculator page. So don't go to Scratchpad. It won't talk to the previous page. I need those variables. So we're going to do one variable stat. So menu 6, been a while since we've done that. Menu 6, 1, 1. Always just choose one list there. The first list is the list, the profit list. The frequency list is the probability or frequency of that happening. Say OK. By the way, as a side note, it does figure out the mean for you. You see X bar, the mean is 3. But what's nice is it figures out the standard deviation, because that's a little harder calculation to do. It's 2.5298. So 2.5298. So, and there is a formula way of doing that. But if we had many, I'll show you that in a second. If we had many, what are these investments, then we would expect that the investments would deviate from the mean or differ from the mean by about $2.5298 million. Is in the context of the problem there. If you look at the answer for 11 on the sheet, you can see that's the formula way of doing it. You certainly could do it that way. It's the probability times the amount minus the mean squared, plus the probability times the amount minus the mean of 3 squared, and so forth to get the 2.53. Then you could do it that way if you wanted to. Okay, so let's say 11 here. So Picard owes its capital source capital fee of $200 plus 10% profits of X. Okay. So the firm actually retains 0.9x minus 0.2 from the investment. Okay. So what is the mean and standard deviation of y? So if you think about that equation here, so they were nice, they give us the equation. So you're multiplying and subtracting. So if you take the mean here and plug it in, so the new mean will be 0.9 times 3 minus 0.2, whatever that is your new mean. Standard deviation is not affected by subtraction at all. So you're just going to take the standard deviation, which was 2.5298 times 0.9, but you do not need to subtract the 0.2. So whatever that is your answer for that one. If you scroll down to 11C, I think I put the work there. So there it is. So those are the two answers you get for that. Okay. 12. The length of human pregnancies from conception to birth varies according to a distribution that's approximately normal, with a mean of 266. Standard deviation of 16. So 280, 16, 282, 298. I hope I'm doing this right. 314. And you can subtract. Minus 16 is 250. 234. And minus 16, 218, I think. Okay. What is the expected difference of the lengths of the two pregnancies? So expected difference of the two pregnancies. So, okay, so the mean is 266. So means work just like normal, right? So you just do 266 minus another one would be 266. So you get a mean of 0. That's nice. Okay. What's the standard deviation of the difference in lengths? So we cannot just add standard deviations or subtract standard deviations. In fact, when you subtract, you still add their variances. So what you have to do is take this and convert it to a variance, square it, plus the variance of the second pregnancy thing, and then take the square root of the total. So you'll type that in your calculator. You get, for number 12, 22.63. Okay, so that's the standard deviation. So find the probability the difference in the length of two pressures is greater than 25 days. It turns out I didn't need to do that. I just am in the habit of doing that. Now we have to, so the mean of the two is 0, and the standard deviation of the two is 22. So I do need to draw this. It would be nice to draw this, 0. So we're going to go 22.6 to the right, 22.6 to the left, add another 22.6, that's 44, 45.2, I think. Subtract negative 45.2, and one more standard deviation as well. So it's greater than 25. So I'm just going to stop there. So 25 is about here. So we're kind of shading this way. So this is kind of the picture of it. I like to draw a picture. It really helps me do norm CDF. So norm CDF, because it's normal. Very typical of a question C where we use the results from A and B to do problem C. Very typical, I would say. Okay, so norm CDF is going to be a lower bound of 25, an upper bound of infinity, with a mean of 0, and a standard deviation of 22.6. So this is standard deviation. Be sure to label this. This is mean, lower, upper. I saw this really messy, but you get the idea. Be sure to label, show your work. You can draw this. We'd love to see the drawing, but definitely show your work for the calculator step there for sure. Okay, 2 more. 13, professional soccer player succeeds in scoring a goal on 84% of his penalty kicks. It's pretty good. Assume that success of each kick is independent. In a series of games, what is the probability that the first time he fails to score a kick is on his 5th penalty kick? So that key right there is the first is geometric, right? So you're going to do geometric PDF, and N is the number. Let's see what we need for that. So let's get the calculator out. So scroll down. Okay, so menu, 5, geometric PDF. If you scroll up, you'll find it. So it asks for 2 things. Probability of success, well, that's 0.84. It's easy. And the X value we want it to happen on the 5th kick. So we get but geometric it's 0. It's 0.8. Sorry, 0.8, comma 0.84, comma 5, and it's equal to 0.00005551. And again, you want to label this. This was probability of success, and this is the K, like the number of successes you want. What is probability that he scores a 5 or fewer on its next penalty kick? So now this looks binomial, 5 or fewer, right? So this is binomial CDF. What a great question here. We got both. 5 or fewer, so 0 to 5 would be up, lower. Mean, let's just go to the command. I forget the syntax, sometimes the order of things on this. So menu 5. Binomial of CDF is B there. So N is number of trials where there's 10 of them. Number of successes, a probability of success is 0.84. Lower bound is 0, upper bound is 5, and it should do that for us. So I guess I had to order this wrong. It should be 10, comma 0.84, comma 0, comma 5, where this is the lower, this is the upper, this is the probability of success, and this is the number. And we should get an answer when we say OK. This is 0.01301. Suppose that our soccer player is out of action for an injury for several weeks. When he returns, he only scores 5 he only scores on 5 of the next 10 penalty kicks. So is this evidence that his success rate is now less than 84%? So let's see how unusual that is. So we just kind of figured that out. So what's the probability of getting 5, or really fewer than 5? Like, let's say you're just out of sync. You're not doing well. So 5 or more extreme than that. So we just answered that with B, right? So that chance was a 1.3% chance. It's pretty unlikely, 1.3%. So do we have evidence? Yes, we have evidence, because there's a 1.3% chance of that happening, of that or more extreme than that happening. It does seem like he's a little rusty from the layoff, right? So I think that's true. Last problem here. Manufacturer produces a large number of toasters. From past experience, the manufacturer knows that approximately 2% are defective. In a quality control procedure, we randomly select 20 toasters from testing. Let X equal the number of defective toasters in the sample of 20. What's probably exactly one of the toasters is defective? So this seems binomial in nature, that the probability set, there's this equal number, set number of trials, it's success or fail, it's either defective or not. They're independent, so it's binomial. So we want exactly one. So I'm going to go binomial PDF, because this is not a range. Let's just do it in the calculator and then get it from that. Okay, so binomial PDF, so menu 55A, I believe. So the number of trials here is 20. Probability of success is 0.02. And we want exactly one that's defective. And so we get 0.272. So this was 20.02 and 1. So this is N, this is P, and this is the number, like K, the number of successes there. Find the probability that at most 2 of the toasters are defective. So at most 2. So this is a range of values. So this is still binomial, but it's now binomial CDF. Hopefully you're getting the hang of that. So we're going to go to that. So menu 55B is CDF, I believe. So number of trials is 20. Probably says 0.02. We want at most 2, so 0 to 2, that includes 2. So it should be 0.9929. And again, you're going to put down the numbers 20, 0.02, and 0 and 2. So this is NP lower upper. Okay. Finally, interpret the expected value of X. So what would the expected value of X be? So it's binomial, right? So the formula is NP. NP. So N times P would be 20 times 0.02. So 20 times 0.02 is 0.4. Okay, so we need to interpret. So if we took many samples of 20, of size 20, of toasters, then we would expect about 0.4 of them to be defective. It's not a percentage, I don't think. That's actually like 0.4 of every 20, to be defective. First I thought it was percentage, but it's not. Find and interpret the standard deviation of X. So I think the formula is square root of N times P times Q. So this would be 20 times 0.02 times 1 minus P, which is 0.98. And you type that in your calculator. So this is 0.63 when you type it in your calculator. So if we took many samples of size 20, we would expect that they would vary. The typical deviation from the mean would be about 0.63. That's good. Okay, that's the screencast.